Hello and welcome back to Engineers Olympiad, where learning meets success. We're discussing the fundamentals and basic concepts of bridge engineering. This is the video lecture number 3. 2 video lectures are already up on the channel. You can watch those videos before watching this video in case you missed them. So let's begin. We studied that bridge is essentially a structure which provides a passage or an obstacle, but without closing the way beneath. Bridge is a structure which provides us with a passage or an obstacle but without closing the way beneath. And in the previous video lecture, we discussed about 7 basic forms of bridges. There are many classifications, but this is essentially a classification based on the type of the superstructure, and we studied that there are 7 basic forms of bridges. And these are the first one, beam bridge, which is also known as girder bridge. Second one, truss bridge. Then we discussed arch bridge. Then we have cantilever bridge. Then we have suspension bridge. Cable stayed bridge. And the last basic form of a bridges are, this is a cable stayed bridge, and the last basic form is a tied arch bridge. All right, so there are 7 basic forms of bridges: beam bridges, truss bridges, arch bridges, cantilever bridges, suspension bridges, cable stayed bridges, or a tied arch bridge, which is also known as a bowstring bridge. This is a classification essentially based on the type of the superstructure we're going to use in particular bridge. We have discussed the beam bridge, the truss bridge, the arch bridge. These bridges are yet to be discussed. So let me wrap it first. In beam bridge or a girder bridge, we studied, let me quickly recapitulate, that deck is supported by means of beams or girders. So in its basic form, all that you need is a cross beam or a girder long enough to cross the 2 abutments, to span over the abutments, and if in case the span exceeds 80 meters, you need to provide supports in the form of piers. So essentially by doing that, for example, you are creating a series of bridges. All right. So this is a beam bridge or a girder bridge, wherein all that is needed are the beams that run parallelly and support the deck across it, so that a span is created between the 2 abutments, and in case the span exceeds 80 meters, you need to add supports in the form of piers, and the loads are carried by flexure in case of beam bridges, and these are ideal for short spans because for longer spans they tend to sag. All right. We're quickly recapitulating the discussions as held in the previous video lecture. Second one, truss bridge. Truss is a structural element which you create by interconnecting various elements to form triangular units. And this geometry gives these trusses exceptional strength and stability. That was discussed. And in case of truss bridges, the bridge deck is supported by means of steel trusses. which are capable of handling dynamic loading because they can absorb both tension as well as compression. They have the capability of absorbing both tension as well as compression. And the loads in case of truss bridge is also carried by flexure or bending. All right, with the top chords of truss, in case of a truss bridge, the top chords are in compression and the bottom chords are in tension. Top chords are in compression, bottom chords are in tension. And let me show you the diagram. This is a truss bridge wherein the bridge deck is supported by steel truss, and the bottom chords of this truss, they are in tension, the top chords are in compression, whereas these vertical or the diagonal members, they can either be in tension or compression. That depends upon their orientation. All right, so this was about the truss bridges. Then we studied about the arch bridges. Arch bridges use one or more than one arches as a structural component. That means in case of an arch bridge, the bridge deck is supported by one or more than one arches, with arches placed beneath the deck. This must be noted because this makes an essential difference between an arch bridge and the tied arch bridge, which we are going to study later on. All right, so in case of arch bridge, the main structural component that is used are these arches. That means deck in case of an arch bridge is supported by means of various arches, one or more than that, and these arches are essentially placed beneath the deck, and the curved shape of the arches has the capability of transferring the loads efficiently. Loads are transferred efficiently, and loads are essentially carried by compression in case of arch bridges, with the reactions at the supports being both horizontal and vertical forces. That was discussed. And the vertical loads from the bridge deck in case of arch bridges are converted into compressive forces along the arch ribs. And while we have heavily praised their aesthetics, but we have also discussed that that can be a limitation in certain landscapes wherein they cannot suit every location. So that was about these types of bridges which we studied about in the previous video lecture. Now let's get started and study the fourth basic form of a bridge, that is a cantilever bridge. Cantilever bridges use projecting beams which are known as cantilevers, and they are supported only at one end. We know that the cantilever is a beam that is fixed at one end and is free at the other. And the bridge deck in case of these cantilever bridges are supported by projecting beams which are known as cantilevers. So these cantilevers form the main span of the bridges in case of cantilever bridges. So the main span in case of a cantilever bridge is formed by these projecting beams which are known as cantilevers, which are fixed at the one end and are free at the another. All right. So typically in case of a cantilever bridge, there are 3 spans. Let me show you in the diagram first. Here it's a cantilever bridge. All right. This is a cantilever span, this is a cantilever span, and this is a simply supported span. So typically in case of a cantilever bridge, we have 3 spans. The 2 outer spans, which are anchored at the ends. This is anchored at this end. This cantilever is anchored at this end. So we have 3 spans, out of which the outer spans are anchored at the ends, and a central span. This is the central span. This rests on the outer spans. It rests on the outer spans. This is the outer span which is anchored at this end. This is the anchored span which is anchored at this end. Then there is a central span which rests on the 2 outer spans. All right. So these bridges are often constructed using steel or iron. We construct cantilever bridges using steel or iron by using cantilever construction. All right. But in addition to this, these cantilever bridges are often supported with trusses. Let me make a diagram for that. So cantilever bridges are those bridges in which the main span of the bridge is formed by using the projecting beam which are fixed at the one end and free at the other. And those beams are known as cantilevers. But in addition to that, cantilever bridges are often supported with trusses. I'll make a rough diagram. And show you how these spans are supported by trusses. So in addition to cantilevers, trusses are also used to support the deck. All right, like so. This is a truss member over here. Here also we have, these are trusses. All right. The function of these trusses is that they take the load off the deck and transfer it to the supporting piers or abutments. This is the cantilever span, this is the cantilever span, and this is the free span, which is a simply supported span that rests on the 2 outer spans. So the role of these steel trusses in case of a cantilever bridge is that they take the load off the deck and transfer it to the supporting piers or abutments. These cantilevers withstand tension in the upper supports and compression in the lower ones, unlike trusses wherein the top cords are in compression and the bottom cords are in tension. But in case of cantilevers, the top cords are in tension, while as the bottom cords are in compression. All right. So this is tension here, tension. This is compression. All right. This again tension. This is compression. Let me summarize it once again. That means, let me show you the first diagram. This one. So the main span of a bridge in case of a cantilever bridges are formed by using the projecting beams which are anchored at the one end and are free at the other. These are known as cantilevers. We have essentially 3 spans in case of a cantilever bridge, the 2 outer spans and the central span which rests on the outer span. All right. But in addition to the cantilevers, these bridges are often supported with the trusses, and their role is to carry the loads from the deck to adjacent piers or abutments. All right. So a cantilever bridge generally consists of 3 spans, of which the outer spans are known as anchor spans. So this is anchor span, this is an anchor span, because they are anchored down to the shore. They are known as anchor spans because these are anchored down to the shore. And these cantilever over the channel, for which we are constructing these cantilever over the channel. And the suspended span is rested at the ends of two cantilevers. This is my suspended span. Or here in this diagram, you can see that this is my anchor span, this is my anchor span, this is my suspended span, because this rests on the two ends of the cantilevers and can act as a either simply supported beam or truss. This central span or a suspended span in case of cantilever bridges can act as a simply supported beam or truss, with the ability to carry their loads by tension in the upper chords and compression in the lower chords. So this is the central span. All right, this is the central span of this cantilever bridge, and this can behave either as a simply supported beam or even as a truss. So here we'll be having compression in the top chords and tension in the lower ones, because in trusses the top chords are in compression and the bottom chords are in tension, unlike cantilevers where the top chords are in tension and the bottom chords are in compression. So this was about cantilever bridge. Now let's study about its advantages and disadvantages. So the cantilever bridges are those bridges wherein the bridge deck is supported by means of cantilevers and trusses, and these trusses take the load off the deck and transfer them to the piers or abutments. And we have essentially three spans in case of a cantilever bridge. The outer two spans are anchored down to the shore. They are known as anchor spans, whereas the central span is known as the suspended span, which will act either as a simply supported beam or a truss. And if it behaves like a truss, then there will be compression in the top chords and the tension in the lower ones. And in case of cantilevers, there is tension in the top chords and the compression in the lower ones. All right, advantages. The first advantage of these cantilever bridges is that they can span long distances without the need for piers in the middle. Number one, they can span long distances without the need for piers in the middle. All right. So these cantilever bridges can span long distances without the need for piers in the middle, thus making them ideal for crossing wide bodies of water, deep valleys, or busy highways. All right. So the first advantage of these cantilever bridges is that they can span long distances without the need for piers in the middle, thus making them ideal for crossing wide bodies of water, deep valleys, or even busy highways. The second advantage is that they are suitable for deep rock valleys and flood-prone areas where supporting structures cannot be built. Suitable for deep rock valleys and flood-prone areas where supporting structures cannot be built. All right, we discussed that They can span long distances without the need for the piers in the middle. That means in those areas where there are deep rock valleys and the flood prone areas and we cannot go for the construction of the piers, that means it makes them suitable for those areas because they have the capability of spanning long distances without the need for piers in the middle. This makes them suitable for deep rock valleys and flood prone areas where these supporting structures or piers cannot be built. So essentially a long span can be created out of these bridges without the need for intermediate supports in between. All right, next one. Little to no disruption to traffic underneath the bridge. Little to no disruption to the traffic underneath the bridge. There is little to no disruption to the traffic underneath the bridge. By this traffic, I don't mean vehicular traffic, but I mean river traffic. All right? And the river traffic is the movement of boats or vessels in a river. So by using by constructing a cantilever bridge at certain area, there is little to no disruption to the traffic underneath the bridge. That is, there is little to no disruption to the river traffic underneath the bridge. Why so? Because long spans are created and there are less intermediate supports or the piers. That means it causes less obstruction or the disruption to the river traffic below the bridge. All right. Advantage number 4. The fourth advantage of these bridges is that on bridges with multiple spans, the cantilevers can be built simultaneously to reduce the time. So the fourth advantage of these bridges is that on bridges with multiple spans, these cantilevers or projecting beams can be constructed simultaneously, and by so we can reduce huge amount of time in their construction. So they are rather quickly constructed. So these were about the various advantages of cantilever bridges. The fourth and the last one that we have discussed over here is that on bridges with multiple spans, the cantilevers can be built simultaneously and that will reduce the time. Now let's study disadvantages. The various disadvantages of the cantilever bridges are, the first one being they are complex to construct and maintain. Complex to construct and maintain. Though in case of multiple spans, we can build these cantilevers simultaneously to reduce the time, but still the construction of a cantilever bridge is quite complex and its maintenance is even more difficult. All right, so this is the first disadvantage. The second one is that it requires a heavy structure, so more material needed drives up the cost. Since it has a heavy structure, I have shown you diagrammatically how we use the cantilevers and then the supporting trusses. So this essentially creates a heavy structure. That means excessive material is used. That means this all drives up the cost. Hence, uneconomical for various situations. All right. The third disadvantage of these bridges is that they're not suitable for excessive climate conditions or earthquake prone areas. Not suitable for excessive climate conditions, or earthquake prone areas. So these cantilever bridges are not suitable for excessive climate conditions or earthquake prone areas because they have less intermediate supports or piers, which makes them unsuitable for those areas which have harsh climate conditions or excessive and which are prone to earthquakes. All right. Next disadvantage is that they experience a high amount of tension during construction. Experiences a high amount of tension during construction. All right. So this is the another disadvantage of these cantilever bridges. And the last one that we are going to discuss over here is that stability relies on balancing. Stability relies on balancing. What type of forces do we need to balance? Both compressive and tensile forces. Since stability relies on balancing both compressive and tensile forces, thus this is a big drawback in case of the cantilever bridges. So this was about the cantilever bridges, and we have studied their various advantages as well as disadvantages. All right, so let's move on and study the next basic form of a bridges, which is a suspension bridge. All right. Suspension bridge. Now, what is a suspension bridge? A suspension bridge is a bridge which carries the vertical loads from the deck through curved cables which are in tension. That means vertical loads from the bridge deck are carried through curved cables which are in tension. And then these loads are transferred. Then the loads are transferred through towers and through anchorages. All right. So the suspension bridge is that form of a bridge which carries the vertical loads from the deck through curved cables which are in tension, and then these loads are transferred to the ground by towers and through anchorages. Let me show you a diagram of a suspension bridge. Here it is. This is a suspension bridge. All right. I'll tell you about the components. I'll write it down and then we'll show you in the diagram as well. Let me rub it first. This is a suspension bridge. These are the components of a suspension bridge. Let me rub it first and write it down first. So the suspension bridge is that type of a bridge wherein the vertical loads from the deck are carried through the curved cables which remain essentially in tension, and then these are transferred to the foundations of the ground by means of towers or anchorages. All right. Components of a suspension bridge. Now we have to study how this bridge assembly works and how this load transfer mechanism takes place. So we have to study about the components of a suspension bridge. First one, flexible main cables. flexible main cables. The second component is towers. The third one, anchorages. Fourth one, hangers, which are also known as suspenders, hangers or suspenders. Fifth one, the deck, of course. And the sixth one, the stiffening system. All right. So the various components of a suspension bridge are flexible main cables, towers, anchorages, hangers or suspenders, bridge deck, of course, and the stiffening system. Let me show you in the diagram. This is a suspension bridge. This is the flexible main cable. This one, main cable. I have written over here, main cable. So this is the flexible main cable. These are the towers, this and this, which are essentially embedded in the foundation below. This is the main cable. We're studying the components of a suspension bridge. This is the main cable, the flexible main cable or the curved cable, which essentially remains in tension, transfers the load. How that is being done, I'll tell you later. So this is the flexible main cable. These are the towers, which are embedded in foundation. Then there are anchorages. This is the cable anchorage on one side and this is the cable anchorage on the other side. Then hangers or suspenders. These vertical lines you can see here, these are the hangers, which are also known as suspenders. So these are the hangers or suspenders. Then this bridge deck, of course, this is the deck of the bridge, this one. And the last component is the stiffening system. This is the deck and stiffening girder. We'll discuss it. Now we'll discuss them one by one. So this was about the essential components of a suspension bridge, where we have the flexible main cable, which are anchored down to the foundation by means of these cable anchorages. Then we have the towers, which are embedded in the foundation. Then we have these vertical hangers or suspenders. Then we have the bridge deck and the stiffening system. All right. Let me rub it first. So in case of a suspension bridge, it consists of a hanging cable, which is known as a flexible main cable. All right. So the suspension bridge consists of a hanging cable, which is anchored at the two ends, already shown you, which is anchored at the two ends. And this cable takes the shape of a catenary. The flexible main cable, or which is also known as a curved cable and remains in tension, this takes the shape of a catenary between the 2 points of suspension. And you know that the catenary is a curve formed by a wire, rope or a chain when it's hanging freely from 2 points that are not in the same vertical line. All right. So catenary is a curve formed by a wire, a rope or even a chain hanging freely from 2 points of suspension. That are not in the same vertical line. Vertical, you must note that, which are not in the same vertical line. So the flexible main cable or the curved cable, in case of a suspension bridge or a hanging cable, which is anchored at the two ends, the cable takes the shape of a catenary. This is a catenary. The cable takes the shape of a catenary between 2 points of suspension. And the flooring of the bridge deck is supported by this cable by virtue of tension developed in its cross section. Already discussed. Let me rub it first. So the bridge deck is supported, or the flooring of the bridge in case of a suspension bridge is supported by virtue of this flexible main cable or the curved cable, which takes the shape of a catenary between 2 points of suspension, the towers, of course. and the loads are carried off the deck or from the deck. Loads are carried off the deck or from the deck by means of these cables by virtue of tension developed in its cross section. All right. And these vertical members, which I told you are known as hangers or suspenders, they are provided to transfer the loads from the bridge floor to the suspension cable. All right. So the load from the bridge deck to suspension cable is transferred by means of these hangers or to suspension cable are carried through these hangers or suspenders. Now, what is the purpose of this cable and tower system? This creates long spans, and the suspension bridge is the only solution for the spans in excess of 900 meters. Those areas where we have to create long spans which are in excess of 900 meters, we have to use a suspension bridge because this eliminates the need for intermediate piers and or other supporting structures for that matter. Let me rub it first and we'll discuss further the suspension bridge. The main cables carry the strengthening trusses by hangers. In addition to this, the main cables also carry the stiffening trusses by hangers. Stiffening trusses is here embedded in the bridge deck. So main cables also carry the stiffening trusses by hangers and transfer the load to the towers. And these cables normally consist of parallel wires or parallel wire ropes of high tensile steel. All right, so in case of a suspension bridge, cables or suspension cable or a curved cable or a main cable which are very flexible are made of parallel wires or parallel wire ropes of high tensile steel. All right. And these towers, they support this one and this one. These are the towers. These towers support the main cables and transfer the bridge loads to the foundations. Because I told you that these towers are embedded in foundation, so they take the load from the cable and then they transfer them to the ground or the foundation below. So the primary function of these towers is that it has to, the primary function is that it has to transfer the load from cable or the cables or the main cable to the ground below or the foundation. But in addition to this, there is also the secondary function of these towers, and that is that it gives the entire bridge a robust, graceful and soaring visual image. You must have seen the photographs of Golden Gate Bridge. That is so beautiful, and it has been also given the status of the most photographed bridge in the world, the Golden Gate Bridge in San Francisco. All right. So besides the primary function of the load transferring mechanism that is being done by these towers in case of a suspension bridge that are embedded in the foundation below, the secondary function is that they give entire suspension bridge a robust, graceful and soaring visual image. All right. While earlier bridges also used steel or essentially used steel towers, but nowadays many constructions have been carried across the world and they have used concrete for suspension bridge towers. Earlier bridges essentially used steel, but nowadays many constructions of suspension bridges that have been carried across the world have used concrete for the main component of a suspension bridge tower. All right, and these anchorages which anchor down the main cable to the ground below, what are these? These are massive concrete structures which resist the tension of the main cables and then transfer them to the ground below. All right, anchorages in case of a suspension bridge are massive concrete blocks or structures which resist the tension of the cable and then transfer the force or the load to the ground below. All right, let me rub it first and then we'll discuss these suspension bridges further. Now these hangers or suspenders, these hangers or suspenders have the role that they have to transfer, hangers or suspenders, they have the role that they have to transfer the load from the bridge deck to the main cable, and these are also made of high tensile steel wires. Hangers or suspenders, they have the role that they have to carry the bridge loads off the deck to the main suspension cable, and they are also made of high tensile steel wires. All right, these hangers are usually vertical, but some suspension bridges have also used inclined hangers. All right, hangers are usually vertical in case of suspension bridges, but some suspension bridges have used inclined hangers. All right, here I have shown in the diagram there are vertical hangers, but some suspension bridges that have been made have also used inclined hangers, and the hangers or the suspenders have the main role that they have to carry the loads from the bridge deck to the main cable or the suspension cable or the curved cable, which takes the shape of catenary between the 2 points of suspension, that is the towers, and is also anchored at the ends by means of anchorages which transfer the vertical loads or carry the tension developed in the cable to the foundation below. All right, now the deck. The bridge deck in case of a suspension bridge, it consists of stiffened steel plate. Bridge deck, we have the deck and stiffening girder mechanism over here. Let us discuss it. The deck in case of a suspension bridge consists of a stiffened steel plate or ribs or troughs and floor beams. The deck in case of a suspension bridge consists of stiffened steel plate or ribs or troughs and floor beams. All right, and the deck may be of strong steel trusses or of streamlined box girder. This deck in case of suspension bridge can be of strong steel trusses or of a streamlined box girder all right, and consists of the bridge deck. In case of a suspension bridge, it consists of a stiffened steel plate, ribs, troughs, and floor beams, and can be essentially made of strong steel trusses or even streamlined box girder. What is the box girder? The girders which are in the shape of a hollow box. All right, that's known as box girder. And why do we use steel box girders in case of bridges? Because these girders are used for long spans, because we already discussed that in case of a suspension bridge we can create spans in excess of 900 meters, and this is currently the solution for those situations where we have to create the long spans without the intermediate supports in between. So these steel box girders, they are used for long spans where the self weight of the bridge becomes a problem, and they have the excellent ability of high torsional stiffness, which can be of a particular benefit. And how it can be of a benefit in case of a suspension bridge, we'll come to know. All right, so a box girder is essentially girder which is in the shape of a hollow box, and I told you that the deck in case of a suspension bridge consists of a stiffened steel plate or ribs or troughs and floor beams, and the deck in case of a suspension bridge can be made of strong steel trusses or of a streamlined box girder. And the box girder is used for bridges in those situations where we have to create longer spans because the self weight of the bridge needs to be minimized, and for those situations where we have to resist the torsion oscillations, and because these girders have the excellent ability of high torsional stiffness, and this can be of great value in case of a suspension bridge, how we'll come to know. All right, in addition to this, there is deck and stiffening system. We have studied what is in deck. Now the stiffening system, which is essential component in case of a suspension bridge. Stiffening system, it consists of trusses. The stiffening system in case of a suspension bridge consists of trusses which are pinned at the towers. And which they have a role, of course, and their role is that they serve to control the aerodynamic moments and to limit the local angle changes in the deck. They control the aerodynamic moments, and in addition to this, they can also limit the local angle changes in the deck. All right, so this is my diagram. This is my deck and stiffening girder mechanism. We have studied the deck, that it consists of stiffened steel plate, ribs or troughs, and floor beams, of course, and can be made of strong steel trusses or a streamlined box girder. And the stiffening system, which is essential component of a suspension bridge, this consists of a trusses which are pinned at the, since I cannot show you a cross section of the deck and stiffening girder in case of a suspension bridge over here, but this essentially consists of the trusses which are pinned at the towers, and their role is that they control the aerodynamic movements and they also limit the local angle changes in the deck. If the stiffening system is inadequate, torsional oscillations, here comes the role of a box girder. If the deck and stiffening system is inadequate in case of a suspension bridge, the torsional oscillations due to what will cause torsional oscillations in case of a suspension bridge? High speed winds. The torsional oscillations due to winds might result in the collapse of the bridge. All right, so this forms the essential component of the suspension bridge, the deck and the stiffening system or the stiffening girder, wherein the stiffening system consists of the trusses which are pinned at the towers, and their role is that they limit, firstly, they control the aerodynamic moments, and in addition to that, they also limit the local angle changes in the deck. If the stiffening system is inadequate, if the stiffening system in case of a suspension bridge is not adequate, the torsional oscillations due to winds might cause the collapse of the bridge. That is why this has to be taken care of, especially in case of a suspension bridges, because high speed winds can cause torsional oscillations which can lead to the collapse of the bridge if we have inadequate stiffening mechanism. That's why the deck and the stiffening system, or the deck and the stiffening girder in case of a suspension bridges, need to be quite adequate, and that's why we use steel box girders in the deck, which have the essential and excellent, I will say excellent, this advantage that they have the high torsional stiffness and they can be of use in certain areas. And in case of suspension bridges, the torsional oscillations due to winds can be resisted by these box girders, and this forms the essential component of the deck and stiffening girder, wherein if our stiffening system is inadequate, it may lead to the collapse of our suspension bridge. All right, let us now quickly recapitulate what we studied about suspension bridge. Suspension bridge is a type of a bridge wherein the vertical loads from the deck are carried through curved cables in tension, and then these loads are transferred to the ground through towers and anchorages. All right, now let's summarize the suspension bridge. We have the components, the main cable, the towers which are embedded in the foundation, then we have the cable anchorages, we have the deck and the stiffening girder, we have the hangers or the suspenders. All right, now the vertical loads, please listen carefully. This is the essential part of a suspension bridge, how its load transferring mechanism takes place. We have studied, now we'll summarize. The load first comes on the bridge deck. All right, the vertical loads due to movement on the bridge deck, the vehicular movement or otherwise, it comes on the bridge deck first. From the bridge deck, it is transferred to the hangars. The hangars have the role, or the suspenders, which they are also called hangars or suspenders, they have the role that they carry the vertical loads that come on the bridge deck, and then they transfer it to the suspension cable or the main cable. Then what is the role of the suspension cable? The suspension cable takes these loads and then they transfer it to the towers which are embedded in the foundation. Then these towers transfer the loads to the foundation below also, and also through the anchorages. The loads are also carried to the ground through anchorages as well, and then to the foundation below. All right, so let me summarize it. Let me rub it down. So the load from the deck, the vertical loads from the deck, or any load from the deck of the suspension bridge, is first transferred to the vertical hangers or suspenders. Though they are usually vertical, but some bridges have also used inclined suspenders or hangers. So the hangers transfer the load from the deck to main cable. Flexible main cable or a curved cable which is in tension. It carries the load from the deck of the bridge by virtue of tension which develops in its cross section. Then load goes to from cable, the load is transferred to the tower or anchorage, both. Then to the foundation below. Because these towers are embedded in the foundation below, and these anchorages are the massive concrete blocks or structures which transfer the loads from the cable to the foundation below. All right, we'll study it again. The load that comes on the bridge deck first goes to the hangar, then to the main cable, from cable to tower and anchorages, and from anchorages and towers to the ground below. This is the load transferring mechanism in case of a suspension bridge. And this distance from the cable anchorage to the tower first is a side span, and this is also a side span, and this is the main span. The span of a bridge is the center to center distance between two adjacent supports or piers or abutments. So in case of a suspension bridge, the center to center distance between two adjacent towers is the main span of a suspension bridge. All right, we have studied the suspension bridge, its components, and the function of each and every one of this. All right, so the load first comes from the bridge deck, then it gets transferred to the main cable via hangers or suspenders, then from the main cable to the towers, and then from these towers to the foundations and the anchorages, and then to the ground below. All right, this was about the suspension bridge. Let me rub it first. Let's study about their advantages and the disadvantages. This is the main cable. This is the shape of a catenary. It takes between the 2 points of suspension. Here, those are the towers, and this is the cable sag. All right, and the catenary is a curve which is formed by a wire, rope, or a chain which is hanging freely from 2 points that are not in the same vertical line. All right, advantages. So you came to know how the load transferring mechanism is being carried out in case of suspension bridges. All right, the first advantage of a suspension bridge is that the construction of piers in bed of river is avoided. This makes it the best bridge for creating long spans with minimum piers. The first and foremost advantage of these suspension bridges are that the construction of piers or piers, howsoever you may like to pronounce them, construction of piers in the bed of river is avoided. That makes it the best bridge type for creating long spans, or the longest spans I may say, and that too with minimum piers. All right, so the construction of piers in the bed of river is avoided, and this is the best bridge type for creating the longest spans, and that too with the minimum piers. The second advantage is that the design is comparatively simple and aesthetically quite pleasing. The design is comparatively simple and aesthetically pleasing. You must have seen suspension bridges, particularly the Golden Gate Bridge, which is aesthetically quite pleasing. All right, so this is the advantage number second, that the design is comparatively simple and they are aesthetically quite pleasing, these suspension bridges. Third one, they're light in weight. Unlike heavy or solid beam bridges, they're light in weight. Fourth advantage, they can be constructed for long spans exceeding 600 meters and can be considered as competitive for spans up to 300 meters. They can be constructed for long spans exceeding 600 meters. Though from 900 meters onwards, we don't have any other choice. We have to just go for a suspension bridge. All right, so they can be constructed for long spans exceeding 600 meters and can be considered as competitive for spans up to or down to, I may say, 300 meters. All right. The next advantage of these suspension bridges is that they can be easily and rapidly constructed, and the waterway can be left open while the bridge is still in construction or under construction. All right. So they can be easily and rapidly constructed, and the waterway beneath the bridge can be left open while the bridge is still under construction. Why so? Because there are least number of intermediate supports or piers in case of a suspension bridge, so they can be easily and rapidly constructed, and the waterway beneath the bridge is least disturbed, can be left open while the bridge is still under construction. All right, so this is the huge advantage of a suspension bridge. We'll study some more. All right, the next advantage of these bridges is that high vertical clearance can be built with high deck, allowing plenty of clearance for passing of ships and other navigational requirements. All right, high vertical clearance, high vertical clearance can be built with high deck, which allows plenty of clearance for passing of ships and other navigational requirements. All right, so this is also the advantage of these suspension bridges, that high vertical clearance can be built with high deck, which allows plenty of clearance for passing of ships and other navigation requirements. And you know that the vertical clearance is the distance between underneath of the bridge deck and the surface below, and in case of a river bridge, it is the distance between HFL and the deck underneath the bridge. All right, and by making use of suspension bridges, we can achieve high vertical clearance. And for example, this is the bridge deck in case of a suspension bridge. This tower, Golden Bridge, it's my Golden Gate Bridge, right? So this is the river body below. You can create high vertical clearance by employing this bridge type, which allows plenty of clearance for passing ships and various other navigational requirements. All right, this is also an advantage of the suspension bridges, that high deck or a high level or a high rise bridge can be created out of this assembly. All right, now with the advantages there comes disadvantages. All right, everything has its pros and cons. Now let's study about some disadvantages in case of the suspension bridges. The first one being, painting is essential for all steel components at regular intervals. Painting is essential for all steel components, that too at the regular intervals. which is a drawback in case of a suspension bridge. All right, so we need painting every now and then for the steel components of a suspension bridge. This is their disadvantage number one. Next one is that the superstructure cost proves to be higher than other types of spans, particularly in the span ranges of less than 250 meters. The superstructure cost proves to be higher than other types of the spans, superstructure spans, wherein particularly in the span ranges less than 250 meters. If the span ranges less than 250 meters are to be created, the superstructure cost for a suspension bridge is more than any other type of superstructure. All right, third one. A combination of vertical pressures and extreme side wind speeds can lead to the failure of the span. All right, so to resist the torsional oscillations due to high speed winds is a big challenge for the suspension bridges, and if there is a combination of vertical pressures and extreme side winds, and our deck and stiffening system is inadequate, that may cause the failure of the span. So if there is a combination of vertical pressure and extreme side winds, all right, that can lead to the failure of the span. If our stiffening system is inadequate, particularly lead to failure of the span. What? So the combination of the vertical pressure and extreme side winds can cause the failure of the span in case of the suspension bridges. The next disadvantage is that the high winds can cause a suspension bridge to start vibrating. High speed winds can start suspension bridge to vibrate. That means suspension bridge can start vibrating if there are high speed winds, which is also a disadvantage in case of a suspension bridge, because if there are high speed winds, it can cause a suspension bridge to start vibrating. All right, the last disadvantage of these bridges which we are gonna study here is that some suspension bridges require extensive foundation work if the ground is soft. Suspension bridges require extensive foundation work if the ground is soft or we have unfavorable soil conditions, or there are unfavorable soil conditions. For all those cases, we require extensive foundation work for the towers. So that is a big disadvantage in case of a suspension bridge, that if there are unfavorable soil conditions or if the ground is too soft, then we require extensive foundation work for the towers of a suspension bridge. All right, so this was about the suspension bridge and its various advantages and disadvantages. So in this video lecture we studied about the cantilever bridges, wherein the bridge deck transfers its load to the cantilevers and the trusses. The trusses and the cantilevers transfer the loads to the foundations, that means via piers or abutments. And these cantilever bridges have essentially three spans: the anchor spans, the two anchor spans which are anchored at the ends, and then there is the central span which can behave as a simply supported span, or that can also behave as a truss. And this suspended span, which is the central span in case of a truss bridge, cantilever bridge, it rests on the outer spans, which are known as anchor span. This is the anchor span, this is anchor span, and this is suspended span. These are anchored at the ends, and this is a suspended span, which essentially rests on the two cantilevers, on the two ends of the cantilevers. And the cantilever bridge is formed by using these projecting beams, which are known as cantilevers, which are fixed at one end and free at the other. All right, so the main span of the cantilever bridge is created out of these beams, the cantilever beams. All right, and the suspended span can behave as a simply supported beam, or even can it behave as a truss, wherein the top members of the trusses, all right, are in compression and the bottom are in tension, whereas the top members or the top chords of the cantilevers, they are in tension and the bottom ones being in compression. All right, then we studied about the suspension bridge, which is our solution for creating long spans without creating much piers or minimum number of piers. And this essentially consists of various components: the deck and stiffening girder, the towers, the suspension cable, the hangers, the anchorages, and the whole assembly transfers the loads from the deck, then to the hangers or the suspenders, then to the main cable, then to the towers and to anchorages, and from that blow to the foundations, because these towers are embedded in the foundation and these cable anchorages are massive concrete structures which transfer the tension of the main cab, this over here, to the ground below. And this flexible main cable, this takes the shape of the catenary between the 2 points of the suspension in case of a suspension bridge. And that means that the bridge deck in case of a suspension bridge is formed of the deck and stiffening girder mechanism, wherein the stiffening system, if being inadequate, can cause the failure of the bridge due to torsional oscillations. And the stiffening system, this usually consists of trusses which are pinned at the towers and which have essentially two important functions. The first one being that they control the aerodynamic moments, and the second one is that they limit the local angle changes in the deck. So our stiffening system and the deck and stiffening system mechanism should be very adequate. Otherwise, the high speed winds or vertical pressures and extreme side winds can lead to the failure of the span along with the bridge to start heavily vibrating. All right, so this was about the suspension bridge and the cantilever bridge, and this is the side span and this is the main span. All right, this is the cable sag. We'll study about the remaining types of basic bridge forms in the upcoming video lectures. Thank you for watching this video.